these are all off of old AP exams. The 89, there weren't, 90 some odd questions on the AP exam, but what they used to do is, especially before it was all digital, it was 1 through 20 something, and then they had this big gap so that it was really obvious that you were in another section, right? And so the later ones were ones where you could use a calculator. So, like, I left the numbers on to say, this is a calculator question, but you can't use a calculator to help you on this. About half or so of the questions on the calculator section of the multiple choice on the AP exam, a calculator won't help you. Part of what they're testing is, do you know when it's a good idea to use a calculator and when it's a good idea to leave it alone? Okay? That's the same, if you want to get a little more philosophical with it, same is true for any tool that you choose to use. Part of it is not just knowing how to use that tool, but part of it is also when should you use that tool and when should you not use that tool. Okay? All right. The other part is that on most of these questions, they don't even mention the mean value theorem, and yet all of these are using the mean value theorem to one degree or another. So for this one, function f is continuous on the interval from -2 to 2. F of -2 and f of 2 are both equal to 0. At that point, I'm already going, yeah, the only way I'm going to be able to keep track of everything they've told me is to draw a picture. I know that f of -2 is 0 and that f of 2 is 0. And I know that f is continuous. Now, do I know what f looks like? No, but I know it's continuous. It says if there is no c, where -2 is less than c is less than 2, for which f prime of c is equal to 0, which of the following must be true? You're like, oh. So what I want to think about is, how could I connect these two with a continuous function where the derivative will never be 0? Because that's what it says. There is no place where the derivative is 0. How could I draw a graph that was continuous from this point to this point where the derivative is never ever 0? Nope. The derivative would, if I drew some sort of quadratic that went through these, the derivative would absolutely be 0 at the vertex. Yeah, that's exactly right. What if I did, and I'm not even going to offset it, what if you did like that? You're exactly right. Some sort of maybe an absolute value function of some kind or another. Then it says, which of the following statements must be true? So let's look at A. Between -2 and 2, the derivative is always positive. Is that possible? And not only, it says must be true. So it's not just possible, has to be true. Well, is it true in this one? No? Well, that's not it. This one says the derivative is always negative. No. The derivative always exists. Does the derivative exist here? No. This one I always thought was weird. The derivative exists. Well, we already eliminated that. And here it says there must be some k in between -2 and 2 where the derivative does not exist. That's the one. Because if the derivative existed everywhere between those two at some point by the mean value theorem, because if I connect those two, the slope of the secant is 0, the slope of the tangent needs to be 0 also. All right, let's go on to this next one. Let f be the function defined by x equals x plus natural log of x. By the way, the graph is for the next one. What is the value of c for which the instantaneous rate of change of f at x is the same as the average rate of change of f over the closed interval from 1 to 4? And even without the number 92 here, indicating that it's in the second half of the multiple choice questions, you would know it from the answers. All right? So the instantaneous rate of change. What's another word for the instantaneous rate of change? The derivative. So f prime of x is equal to 1 plus 1 over x. And the average rate of change is going to be 4 plus the natural log of 4 minus 1 plus the natural log of 1 all over 4 minus 1. And although I don't always take the time to simplify this, I am on this one because it's 4 minus 1, that's 3. And natural log 4 minus natural log 1, what is natural log of 1 equal to? 0. So that's just 3 plus the natural log of 4 over 3 is equal to 1 plus 1 over x. So, like Sam and I were talking about earlier, you don't want to do a lot of work on this since this is a calculator problem. Put both of those in and see where they intersect. So wake up, go back to that, clear this out. So I want 3 plus the natural log of 4 over 3 to be equal to 1 plus 1 over x. And I have no idea what my last is, so I always do a zoom standard to start. The first should be a constant function, and it is. And you can barely see somewhere up in here, those two crossed one another. Okay. So, second trace, find the intersection of those two. I want you to notice all of my answer choices are between, say, 0.4 and 2.5, right? So that's a smart thing to put in when they ask you. Oh, by the way, on this, where the second curve, because it's not defined at 0, it freaks out unless you move it over a little bit. Okay, so guess something between 0.4 and 2.5. Oh, I'll guess 1.7. I have 0 idea. I don't think that's even close. 2.164, right there. So that's the mean value theorem. It didn't say mean value theorem anywhere in it, but you're using the mean value theorem. All right, let's move on to some free response questions. Wow, I've got a lot of free response questions. We probably will not get to all of them. So let's look at this one. A continuous function f is defined on the closed interval from -4 to 6. The graph of f consists of a line segment and a curve that is tangent to the x-axis at x equals 3 as shown in the figure above. On the interval between 0 and 6, the function is twice differentiable and the second derivative is always greater than 0. The stem of the question tells you tons of information. Not all of it will apply to every subpart. But let's look at part C. Is there a value of a, where a is between -4 and 6, for which the mean value theorem, applied to the interval from a to 6, guarantees a value of c between a and 6 such that f prime of c is equal to 1/3? This problem destroyed a lot of people because there's just so much in it. And once you see it, it's really easy, but it's kind of a light switch kind of thing. So first of all, it says, I'm going to apply the mean value theorem on an interval from a to 6. Well, it's pretty clear that this function f is not differentiable at 0, right? So I know that a has to be 0 or larger. Okay. Also, I want to have f prime of c equals 1/3. In other words, remember that that's the instantaneous rate of change. I want the average rate of change to be 1/3. So take a look at this. On what interval is f's average rate of change 1/3? Well, 0 to 6, the average rate of change is clearly negative. You can't go, so remember we said we're trying to go from a to 6 and we can't go across this point. 0 to 3, that's going to be negative. 3 to 6. The average rate of change there is 1/3. So I'm going to say yes, and I'm going to be more specific, although they didn't ask for the value, at a is equal to 3. And they want me to justify our answer here. So to justify that the mean value theorem applies, on the closed interval from 3 to 6, what needs to be true about f? On the closed interval, just continuous. And on the open interval from 3 to 6, f is differentiable. Now, how do I know it's differentiable everywhere in there? Notice that it says that on the interval from 0 to 6, the function is twice differentiable. If it's twice differentiable, that must mean that both the first and the second derivatives exist everywhere between 0 and 6. since the average rate of change of f on the closed interval from 3 to 6 is 1 minus 0 over 6 minus 3, which is equal to 1/3. The mean value theorem on the interval from 3 to 6 guarantees a value C where A is less than C is less than 6. And I guess we'll go ahead and use 3 because 3 was the value of A, at which f prime of C is equal to 1/3. And notice, the end of my question, I'm just parroting what they asked. Right? A lot of times students get all tangled up in the wording of things, and one of the ways that you can help yourself is to parrot their question right back at them when you're justifying your answers. All right, let's go on to the next page. All right. Oh, and by the way, the question numbers on these are like, why are there 2 3s? Did Mr. Davis misnumber these again? No. I don't remember when it changed, but I looked at a whole bunch of old ones for this. On the old AP exams, 1 through 3 were with a calculator, 4 through 6 were without. So that's why I left those numbers on there so we can see this is a calculator problem. It's not going to help you, but it is a calculator problem. All right, so it says the functions f and g are differentiable for all real numbers and g is strictly increasing. The table above gives values of the functions and their first derivatives at selected values of x. The function h, why do they have to do this? Because this is what the AP exam does. Is given by f of g of x minus 6. Explain why there must be a value c between 1 and 3 such that h prime of c is equal to -5. You should, as soon as you see this, you should go, oh yeah, that's the conclusion of the mean value theorem. Right? That's the conclusion, that there's some value c between these two such that the instantaneous rate of change is equal to, this should be the average rate of change. So we need to first go through what are the things that are necessary before we can apply the mean value theorem. So we need to talk about h of x. Is h of x continuous? Well, if f and g are differentiable for all real numbers, f and g have to be continuous, right? Differentiability implies continuity. So since f and g are differentiable, for all real numbers, they are also continuous for all real numbers. And therefore, h of x is continuous for all reals. And differentiable for all real numbers. So we've checked the requirements of the mean value theorem. And let me just say, when you're doing that, if you're not sure how to make a connection to it, just go ahead and say that they're continuous and differentiable anyway. Right? Sometimes you'll get a point or two for that. So on the closed interval from 1 to 3, the average rate of change of h of x is f of g of 3 minus f of g of 1 over 3 minus 1, which is equal to f of, let's see, g at 3 is 4, so that'll be f at 4. And g at 1 is 2, so minus f of 2 all over 2. F at 4 is negative 1. F at 2 is 9. So that's negative 5. Therefore, by the mean value theorem, and here I'm going to just parrot back what they said, there must be a value c for 1 is less than c is less than 3, such that h prime of c is equal to negative 5. So notice on this one, they never mentioned the mean value theorem. You have to recognize that what they're giving you is the conclusion of the mean value theorem and go, okay, can I apply it? All right, we're not going to get to all these, but it's not a bad idea to take a look at these.